Hello and welcome to the MecSoft demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mecsoft.com. Without further delay, we invite you to sit back and enjoy the demonstration.
Now, the first thing I'm going to go over or talk about is how we could program indexed 5-axis, or also known as positional 5-axis, and then we'll take a look at a simultaneous 5-axis as well.
Okay.
All right. So what I'm going to do here is go ahead and load one of these parts in here for our training session.
Okay. Yeah. Got it. I recognize the files.
Okay. Great. So as you notice here, as the part is loaded, the VisualCAM interface shows up inside of SOLIDWORKS. Now in SOLIDWORKS, you can create drawings, you can create parts, and you can create assemblies. Now the VisualCAM plugin will load when you open a part. So the CAM plugin will only work inside the part document, not in an assembly or in a drawing. So you can convert a assembly to a part in SOLIDWORKS. If you have a drawing, you can import it into the part workspace, and you can work with it too.
Okay, not in draw, not in assemblies, but in part and what do you say? In turn? No.
In part, in the part module. So if you select, if you click on a new part, if you click on File and New, SOLIDWORKS allows you to create a part, an assembly, or a drawing. So
here
the CAM plugin will load in a part document.
Okay.
If you have an assembly, you can save the assembly out as a part. From an assembly, you can save it out, so it'll be multiple parts. You could have multiple parts. Okay?
Yes.
So we have this part loaded in here. Typically parts have extension .sldprt, as you see.
Okay.
Now your VisualCAM interface shows up as a tab in the command manager. So this bar up at the top is called the command manager in SOLIDWORKS. You could create sketches, you could extrude, create solid modeling. So these are the different tabs in SOLIDWORKS. Now, and the VisualCAM's interface shows over here on the left pane. You can resize the feature manager tree over here to view all of the commands under the machining browser. So the machining browser and the machining objects. Now, the interface looks very similar to what you've used to in our CAM plugin for Rhino.
Yes, I am totally sure of that. I am watching that right now. It looks pretty similar.
Okay, so now if you go over to the feature manager design tree, this shows all the features, how the part was designed, the feature tree in SOLIDWORKS.
Okay.
And if you click on the VisualCAM tab, you will see that the CAM interface shows directly inside of SOLIDWORKS.
Okay.
Okay, so the typical workflow here is you go over to the Program tab and you define the machining process. Now there's an additional tab that shows up in SOLIDWORKS, our plugin for SOLIDWORKS, which is not typically common in the standalone or the plugin for Rhino, because in Rhino and in VisualCAD you can rotate the part around easily.
Yeah.
In SOLIDWORKS, it's modeled parametrically, so you got to insert a feature in the tree if you need to rotate the part. So rather than rotating the part, it is easier to just rotate the coordinate system for machining. Now you got to define your initial orientation. Now by default, VisualCAM uses the same orientation as the world coordinate system that you have in SOLIDWORKS. Your Z-axis is in the same orientation as the machine coordinate system, Z-axis, and then your X and the Y. Now, if for any reason you want to start by setting the Z to be normal or perpendicular to this face, then you can establish this by changing. Rather than having to rotate the part in SolidWorks, you just rotate the coordinate system in here, where I can choose to rotate it, so I can put the Z to be normal to this particular surface.
I understand.
So this is one of the key differences between our RhinoCAM or VisualCAD standalone versus the plugin for SolidWorks. So you establish, rather than rotating the part and moving it to the origin, you would use the Machine Tool Coordinate System tab to basically align the coordinate system for the XYZ orientation of how you're going to be placing the workpiece on the machine tool.
Okay. We don't, I mean, in SolidWorks, we don't rotate the part, the model, but we use this tab in order to rotate the coordinate systems of the software in order to match the orientation with our CAM.
That is correct. You're absolutely right. Now also you have the option to establish the origin. So typically for 5-axis machining, you would establish the initial orientation and an origin, and all of your toolpaths would be computed based off the initial orientation and origin. Now again, the origin is by default set to where the origin is in SolidWorks. So if you go over to the feature tree, you'll see that the origin is right here. This origin in the tree points to where the origin is, where my cursor is on the model. So by default that's the origin location, but you can change it. If you want to move the origin to a different spot, you can hover the mouse and cursor pick, and you can specify it, you can pick a point. So this will change the XYZ0 origin. So again, rather than moving the part to XYZ0 in your CAD that you typically are familiar with doing it in Rhino or in the standalone product, in this particular setup, you just pick where the origin needs to be. So you establish that.
Let me ask you a question. And that origin would be represented by the G54 when we start to create the program, or
yes. If you're programming a 3-axis machining operation, you could add a work 0 to establish the origin. So in the case of 5-axis machining, you want to make sure you establish your initial orientation and origin, because all the toolpaths will be computed based off this origin. So when you post it, everything would be computed based off this origin. Now, if you're just programming a normal 3-axis operation, after you establish this XYZ orientation, you pick OK to accept it, and then you can create your stock and insert what is called a work 0, which allows you to establish the orientation for it. So you can then add a work 0 and choose where you want to place the origin. And this could be your G54 or G55, whatever the work coordinate offset is. So this would be the typical case for 2 and 3-axis machining. In the case of 5-axis machining, even if you place your work 0 over here and your initial origin is defined over at this point right in here, right?
See, I'm sorry, it's so loud. I'm sorry, yeah.
So when you post-process toolpaths in 5-axis, you have this option to output all coordinates in local orientation or transform them back to the world. So typically in 5-axis machining, you would want to transform this back to the world coordinate system origin. And that's why it'll transform it back to the initial origin and not just to the work 0. So that's the reason why when you do 5-axis indexed or 5-axis simultaneous programming, you would want to establish your initial orientation, because even though you add a work 0, it'll first still go back and transform it to this position.
Okay. Yeah, and that is so important. That's the reason, because it's so important to write, choose this position at the beginning of everything, all the process.
Right, because there's only one origin that you typically reference out of when you do 5-axis programming.
Now, normally when you just turn on any machine, you know, the machine by itself runs a small program for make a quick run all the X, all the Y, all the Z, and return to the machine home. I'm not sure if you know that. I'm pretty sure that yes. It's like called home or house machine. That origin of the machine by itself is related with what? With the UCS of the SolidWorks, or is related with this coordinate or origin that you are showing me right now?
So by default, the orientation is same as the orientation of the coordinate system in SolidWorks, and the origin is at the origin in SolidWorks.
Okay,
by default,
yep,
by default, yes, and match it. Now, typically users may not be using this orientation or origin when they design the parts and when they create the drawings, because they're probably not taking into account that, you know, how it's going to be machined, because the design engineer is not aware of how the CNC programmer or the user is going to machine it. So that's the reason why you have all of these nice controls in here to establish the orientation and also establish the origin.
Okay.
Okay. Now, if they design using the correct orientation, then you don't have to go through the step of reorienting your coordinate system or the origin in using the VisualCAM's machine tool coordinate system tab.
Okay. So basically, if the engineer doesn't want to be really in deep of this, I can jump and just make sure that the matching is automatically.
Yes.
Right?
Yes.
Okay. Just one question here. Spin angle, this 90 degrees normally make me crazy. What is this? Is the angle for the spinning of the what's the name of spindle? Is 90 degrees because the machine is vertical, and when we use a horizontal machine, I have to set here 180. Is that correct, or is a mistake?
This is to change the orientation of your XYZ coordinates, like rotating your coordinates. Now consider you have your gumball in Rhino. Is that right? You're familiar with the gumball, right? So if you want to rotate your coordinate system, so you want the Z to be perpendicular to this surface or this face, you would want to rotate it 90 degrees about the x-axis, right, using the right-hand thumb rule. So if you put in spin angle 90 and click on the x-axis, you will notice that now it's rotating the coordinate system about the x-axis by 90 degrees so that the Z is perpendicular or normal to this, the front face of the part.
Exactly.
So now you can use these angle, you can specify an angle, and also you can specify you want to rotate X, Y, Z, or a combination of these. Now if I want to rotate it to this face, I could do 90 degrees about X, and also I can do a 90 degree about Y. Now the Z axis would be normal to the right side face.
Okay, because I think that is used in some moment for 4-axis programming when you want to use the turning feature. Is that correct?
When you do 4-axis programming, you're going to do rotate table setups rather than using this machine. Yep. And you specify the rotation angle about the axis of rotation that you've defined. Okay?
Yes.
All right, so now here we're going to go back and reset it to the world coordinate system, the same orientation. So when we want to start machining this part, we're going to basically place the block so that this feature will be looking down through the machine tool as you want to mill this. So you have your X, Y, and the Z orientation, and the origin is over at this corner. Okay? Now we established that. Now the next thing we want to do is go ahead and define the machine type. So we're going to set the number of axes to 5. And the configuration of the machine tool. We support 3 different configuration types. These are head-head configuration, where the 2 rotational axes is on the machine tool head, which means the part would remain stationary on the bed of the machine. The part won't be rotating. The machine, the tool on the spindle would rotate to get to different orientations.
Yes, all the A and B movement will, and normally the Z will hold in the spindle in the head, right?
That is correct.
Yes, yes.
We also support machine configuration for table head, where one of the rotation could be like a 4-axis, like an X-axis or Y or Z axis, and the other could be on the spindle. So a combination of a rotary table and a rotary head.
Table A, head B, something like that.
Yep.
Plus,
A and B or C and B or A and C, whatever the conventions are used for representing the head.
Okay, perfect. Yeah, understood.
We also can support table configuration, where the table would be rotating. There would be 2 tables, one on top of the other, like a trunnion. It's also known as trunnion type of machining, where you have 2 rotary tables, and the part would rotate, and the tool would remain perpendicular to the XY plane of the bed of the machine. So the part would be rotating. So typically, like when you machine like impellers and small parts, where it's easy to rotate the part rather than having to rotate the head. So like there are several machine tools which do trunnion type of machines.
Okay,
So these are the 3 different configurations. So now you pick a configuration. So we'll go with the standard type of configuration where a head. Now if you go to the help section in here, it actually talks about an example of the head. So you can see that there's a C axis which rotates about the parallel to the Z, and then the B axis could be rotating parallel to X or Y. So this is called a head configuration.
Okay, understand.
So in the typical case of a head configuration, your primary axis will always be rotating about either Z positive or Z negative. So depending on how the machine tool is defined, Z positive or Z negative. So if it's Z positive, you'll see that the Z axis rotation direction is pointing up. You see the green arrow along with the Z axis right here.
Yes,
that's the primary. So if you point your thumb in the direction of the arrow, so if you do a Z positive, if you do a right hand thumb rule, so as you roll your wrist towards you, that would be a positive rotation. As you roll your wrist away from you, it'll be a negative. You can switch between Z positive or Z negative. So depending on which way the machine tool is set up. Similarly, you can also do the coordinate system orientation for the secondary axis. The secondary axis for a head machine could either be along X or could be along Y. You can see the red arrow here represents the Y positive, or you can have it set to Y negative. Again, this depends on how the machine tool is set up. So you define these 2 in here, and you can also specify the limits for the rotary axis. Typically for the primary axis, it could be a no limit, or if you have like cables or something in the way, you may have a limit where it can only go like plus or minus 360 or just 0 to 360 only. So you can specify the limits for the primary axis, or you can even input a user-defined limits in here, minus 3 to plus 360 degrees, for example. It could be possible, right? So you specify the limits for the primary axis. You can also specify the limits for the secondary axis. So in this case, the secondary axis is a head, so the head can go plus or minus 360. You might be only able to go like minus to plus 110 or 115 degrees. So you can specify them as user-defined limits in here, so how far the head can tilt, right?
Okay, yes, I understand. And I have to check really well the features of the machine in order to set correctly those degrees and those features there in RhinoCam.
Right. If you look at your yes, if you look at the machine tool specification provided by the machine tool vendor or manufacturer, they would tell you the rotary axis limits of primary and secondary, and they will provide you with most of the information. And in here, you have a parameter called gauge length. Now, gauge length is required where you have a machine that has a head. Any combination with the head will have a gauge length. Gauge length is the distance from the pivot point that you see right there, where the point about which it rotates, to the tip of the tool. So what you're inputting here is the distance from the pivot point down to the spindle face, and then
Yeah.
tool length that you define in your tool definition is automatically added to it when the gauge length is specified in here. So typically the gauge length is a constant parameter for a given machine tool, the distance from the pivot point to the spindle face, but the tool length would vary depending on how far the tool is you know sticking out from the spindle face to the tip. So you put in the gauge length. It could be, for example, 6 inches. I'm using a number here, right?
Yeah.
Now the gauge length parameter can only be entered when this box is not selected. So if this box is checked, then it's going to output every coordinate system in the local coordinates, like a rotated coordinate system. But when you uncheck this, it'll transform everything back to the world coordinate system orientation. That's what most machines expect in 5-axis, is transform back the coordinates to the world. So in this particular case, if you're milling this particular face, your cutter is moving in and out along the y-axis. If you're cutting on this face, your cutter is moving in and out along the x-axis when you look at it down from the top, looking down from the world coordinate system orientation. So unchecking this box will transform this Z motion into the motion that is in the world coordinate system. Am I making sense?
Yes, yes,
Okay,
yes. So
perfect.
that helps to manage just one coordinate system for the whole part.
That is
because
correct.
you have. Okay, I understand.
Alright, so now you define the machine tool. The next step is to create your stock material. So when you pick stock, box stock, this will compute the length, width, and the height. Very similar to how you define your stock for 2 and 3 axis operations. Okay? Now also, by default, the setup coordinates is automatically oriented to the machine coordinates. So whatever you define in here is inherited automatically by the initial setup coordinates.
Okay.
Okay, now we want to go ahead and create the toolpath. So I'm going to start out with a toolpath in here. So I want to do a roughing operation. I could choose 3-axis or a 2-axis operation. I pick roughing. I can now select my geometry for roughing in here. I could say I would like to keep the cutter completely inside this area, so I can select a chain of edges, or I can do select tangency or select loop. These are the selection tools that are offered in SOLIDWORKS, where you can automatically do a chain of edge selection, similar to how you can use in Rhino, like using the chain command to select chain of edges. And then the workflow is very similar. The interface looks very similar as you see it. You specify your tool, you set your feeds and speeds, you establish your clearance, you specify your cutting parameters right in here, you can specify your cut levels, and then you hit generate, and this will automatically establish your toolpath. So there's your roughing toolpath for the top orientation. Now you can go ahead and run a verification, and you'll see that the roughing toolpath is being simulated right in here.
Cool. That part is really clear for me. It's no problem. I manage that. It's okay.
Right. And now you can go from a roughing operation to a finishing operation. You could program a horizontal finishing, or we could do a 2D pocketing, depending on the type of operation you'd like to program. You specify the cutting parameters in here, and you click on generate. So this would produce a finishing toolpath around those areas. So since you're familiar with how to program your toolpaths, I'm not going to spend a lot of time on this here. Again, if you want to do a pocket or drilling, you can drill or pocket these holes. Now once you're through programming this top face in here, let me go ahead and just add a drilling too. So we'll just do a drilling, and we'll say select holes on this particular face. We'll pick that. We'll go grab a tool for it, and then we can specify a depth, so you can measure or pick the depth from the face.
And once I remember that you tell me that it depends on what kind of a strategy for drilling, the machine, the software will create some of those scan cycles, that I think it's G78,
G81, G83, yes, it creates scan cycles. Now with our 2017 version, we've introduced an option to output them as linear motions. There are several machines which do not support or handle scan cycles. So when you select output as linear motions in version 2017, we automatically convert these to a linear motion. So rather than outputting them as a CAN cycle, it'll output as a linear motion.
Okay.
Okay, so now we programmed from the top orientation. Now you want to go ahead and program it from the sides. So the way you would program it here is this is what you would start programming indexed 5-axis or positional. So you go ahead and add a new setup by going to Setup under the Program tab, and you click on Setup, and this will allow you to change the orientation from which you want to machine. So now I want my tool to be able to cut these pockets. So I need to change the orientation, so I could rotate it. In this particular case, I could say perform a 90-degree rotation in here, so the tool would be normal to the surface. Or if you're not sure what the rotation angle is, you can use select the surface, and I can just pick this face in here, accept it, and you will see that now the z-axis is oriented based on the surface normal. Now if you need to flip the normal on the surface, you can go ahead and rotate it in here by using the controls. I can rotate the coordinate system right in here.
So I press Control and make a click and specify in the axis that I want to flip.
Absolutely. You click on the axis that you want to rotate about.
Okay.
So now you'll notice that your coordinate system is rotated. The setup 1 was parallel to the top face. Now the setup 2 is parallel to the front face.
Oh, okay. Good.
Now you can add operations, very similar to how we program it. So I can repeat the same roughing operation. I can copy it from one setup down to the next setup in here. I can make edits, make changes. I can also specify cut levels and say this is how far I want to go. So you'll notice that your cut levels, your clearance plane are automatically oriented in the same orientation as the coordinate system. And now you pick generate, and this would produce your roughing toolpath for the new orientation, and you can run a verification in here.
And we make that in an indexed way, right? We need to turn the part in the machine, and when the moving is completed, the turning is completed, the machining will start.
That is correct. In this particular case, we are looking at a head-head configuration, which means the part would remain stationary, the orientation of tool would change to be able to program from this particular orientation. Now if it's a table or a table head, the part would be rotating on the machine.
Okay.
So again, it depends on the type of 5-axis machine configuration you currently have or your customer is going to be using.
Okay.
So now,
and
I'm sorry, go ahead.
just for understand, if it's the configuration table head, basically I follow the same procedure, but probably the program at the end will send or will post-process a program, a G-code that manage or handle the continuous movement between the axes.
That is correct. So depending on whether it's a head-head, table-head, or table-table configuration, the steps that you're going to be doing for programming the toolpaths are going to remain the same. The output, the computation is automatically handled based on the configuration and the primary and the secondary axis that you define. That's what basically takes care of the computation of the angles, whether to rotate the table or to rotate the head or to do a combination of both. If it's a table head machine or if it's a table machine, it'll figure out what angle to rotate the primary and what angle to rotate the secondary axis by, so you don't have to worry about those computations.
Cool. So basically I keep working as between quotations as 3 axes, and the program by itself will handle and manage all these kind of tricky parts with mathematicians and angles and everything.
That is correct. So we've got through the programming of the setup number 2. Now we can repeat the same process for setup number 3. So I'm going to now rotate it to the right face. So I can either use select a surface, I can just pick that face, and you'll notice that the surface normals, based on the orientation of the normal, it'll orient the coordinate system. And if you need...
We need to flip. Why? Yes, exactly. Okay, good. Yes.
And then you can repeat a roughing operation, or if you just want to do like a 2D pocket operation, you can program a pocket operation in here. So you could do a 2-axis pocketing. So you could do a combination of 2 and 3-axis operations in here. You can specify the tool. You can establish your cutting conditions in here. You want to go from this face down to the face right here. So the depth is automatically computed based off the orientation of your coordinate system, and you can specify your depth per cut. And then generate would create your toolpath. So this is how you go about programming it from different orientations.
Just one question, my friend, just there in that point. That steps works because the last surface that you selected is flat and also parallel to the external surface. But if it's not flat or is not parallel, it works in the same way?
Well, you need to have a planar surface if you want to use that for orienting your coordinate system. Now, if you have a sculpted surface, then you can rotate it by an angle, maybe like a 45 degree, or so that the tool will be able to machine those features and there aren't any undercuts by looking from that orientation.
Okay. My mouse is not helping to show you where, but no problem.
Yeah, I can give you access for keyboard and mouse, and you should be able to point it to me right now.
I was talking, by here. First, we choose this as reference, right? And then we choose this another surface, and I was talking that this surface is, of course, planar and parallel to this one. But if these have an angle or is sculpted, this procedure have to be different.
You would still be setting the z-axis normal to this particular surface, but then you would program a 3-axis roughing and a finishing toolpath rather than using a 2-axis operation, since the floor of the part is not planar. So you would have to, or it's in an angle not planar with the orientation, so you would basically have to program it with a 3-axis toolpath.
Will work better. Yes, I understand.
Yes. Once you have all of these programmed, you have your post. We would need to provide you a 5-axis post. We would need to develop one based on the machine configuration, so we can take one of the existing 3-axis posts and we would have to update it to a 5-axis. So once you have it set up in here, right-click and do a post all. Will post and compute the angles for each of these orientations.
Wow. Okay. So that will make easy everything.
Yes, so I'm going to go ahead and show you a sample output in here, so just give me one moment.
Access, but I understand pretty much all your explanation until this point.
Okay, so we've developed several different posts for a variety of different machines. So in this, for example, I could choose maybe a post for a Fager controller in here, like a Fager 8055.
Or they have is Shopbot 5-axis.
Okay, so we do have post for Shopbot in here. We can output in inches or we could output in millimeters. I'm going to select the inch post processor, and I would set the output extension as .sbp. So I would use .sbp as the file extension, and right-click on the machining job and you pick Post All, and this would create your G-code output. And you will notice that in your output, the M5 represents a 5-axis motion for Shopbot. So it shows that for the initial orientation for setup 1, it's at 0, 0. For the Shopbot, so because we are doing the top orientation, and then when you do a search for the next M5 in the program, you'll notice that it's rotating by 90 and minus 90 to get to this setup orientation number 2. So it's automatically computing the rotations. Now the Shopbot machine is a head-head configuration, so now you see that the angles are being outputted, so it's rotating 180 and then by minus 90 to get to the next side, which is
right position for the next machining.
That is correct. So it automatically determines the angles for you. So this is how you would go about programming indexed 5-axis operations. So You would create a setup for each orientation, and then you would program 2 and 3 axis operations. Okay?
Yes, understood.